Hello friends, myself Dr. Sarika Kalra, Associate Professor from Ajay Kumar Garg Engineering College. I am taking the subject of electrical machine and this is my lecture 7. In the last lecture 6, I have discussed about the how to determine the parameter of the equivalent circuit test of the equivalent circuit of the transformer. And for that we have performed two tests. One is the open circuit test and second is the short circuit test. So in today we see the how to perform the short circuit test, and the last lecture we have already seen the open circuit test. So in open circuit test we have seen that it is always performed at a low voltage side, and second thing, it is always performed at a rated voltage, and as the name is open circuit, it is always at a no load. That means the secondary winding is open circuit. And with this output, with this test, we can why you perform this test. So we conclude that with the help of this open circuit test, we can find the parameter of the parameter of the equivalent circuit, that is no load parameter. We can find the no load parameter of the equivalent circuit of the transformer. And second thing we get the power loss, that is core power loss, because in the open circuit test is always at a no load. That means the magnetizing current is flowing in the primary only. Primary winding contain the only the no load current, and that no load current is that is exciting current, and it is always in transformer 1 to 6% of the, or you can say 2 to 5% of the rated current. So if the rated current is so small, the no load current is so small, the I square R losses are very less. So we can neglect this I square R loss in comparison to the core loss, because core loss are depend upon the voltage, and in open circuit test we perform the open circuit at a rated voltage. So we can, so the wattmeter reading always gives you the total power, which we can assume that it is all the core loss, because we can neglect the I square R losses. Okay. So with the open circuit test, you will find the parameter, like two parameter, no load parameter XM and RC. Just we see the XM, sorry. So in the last lecture, lecture 6, we have seen that last lecture we have performed the open circuit test, and it is performed at a low voltage side. Second, it is always performed at a rated voltage, and third, it is performed at a no load current or the secondary open. It is performed at open circuit, that means secondary is open, or you can say the no load current or I2 is 0. So the current is only the no load current. So current flowing in open circuit test is only the exciting current. Okay. And by this, after performing this test, we can able to find out the parameter like RC and XM, that is no load parameter. And second thing is, we find the core losses. because in open circuit test wattmeter give you the total power which is consumed by the transformer circuit, but as we see it is it carry only the no load current. So, the I square R losses in R1 and RC is very small. So, and it is performed at a rated voltage. This core losses depend upon the voltage square. So, if it is performed at rated voltage, core losses can be, the I square R loss can be neglected with the core loss. So, in open circuit we have find this RC and XM and the core loss. Okay. Now, today's lecture we will see the how to perform the short circuit test. So, first we see the how to connect the, when you perform this short circuit test, how to connect the circuit. So, this is auto transformer, emitter, there is a wattmeter current coil and the pressure, this is the current coil, this is the pressure coil of wattmeter, MLCV connections, and this is the transformer winding, primary winding, and this is secondary winding. So, here you connect the voltmeter. Here the supply is there, the single phase 50 hertz supply. Okay. So, in short circuit test we connect the two winding, we are going to perform the short circuit test in two winding transformer. So, you connect the two winding transformer in this manner. Okay. We apply the voltage through this auto transformer, this is auto transformer, and we short the secondary winding. Okay. So, in open short circuit test, first it is performed at rated current, second it is performed at high voltage side. It is always performed at a rated current, and it is always performed at a high voltage side. Okay. So, if you see the block diagram, the equivalent circuit at short circuit, because this short circuit test is performed at a rated current. So, the no load current in transformer is 1 to 6% of the rated current. That is very small. So, you can neglect this no load branch in comparison to the rated current, because the short circuit test is performed at a rated current. So, we can neglect this RC and XM branch. The circuit become this circuit, and it contain the resistance and the reactance of the primary and as well as the secondary winding. Okay. So, when you shorted the circuit, it is, I mean, have the minimum impedance, minimum resistance or the impedance. So, very less voltage with applying a very less voltage, this will carry a rated current, the short circuit current, or you can say the rated current. So, that is why the short circuit test is always is performed at a reduced voltage, perform at okay. How it is, why it is performed at reduced voltage? Because at reduced voltage, at this short circuit test, because it is performed at a rated voltage, and when it is short circuited, the resistance will be minimum, or you can say the impedance will be minimal. So, to apply you will get this rated current by applying the very low value of voltage. So, that is why it is performed at a reduced voltage. So, these three conditions are to be used to perform the short circuit test. First is, it is performed at a rated voltage. To achieve this rated voltage, only very less voltage is required, because it is a short circuit, it experience a low impedance. And second thing is, it is always performed at a high voltage side. We will see in this coming slide ki how this why the open circuit is always performed at a low voltage side and the short circuit is always performed in the high voltage side after this slide. So, this is the equivalent circuit of the for the short circuit test, and when you experimentally perform this test, you will get the ammeter reading, this ammeter reading, the wattmeter reading and the voltmeter reading. So, suppose ammeter reading is this is suppose I, that is obviously it is a rated current, and the voltmeter gives voltmeter reading, volt or the voltmeter reading gives you the voltage, the reduced voltage at which you perform the short circuit test. And the wattmeter reading. That is omega. So, in this case you see that wattmeter reading is the reading, that is wattmeter gives you the power, which is this wattmeter gives you the power which is consumed in the short circuit test. Okay. This is shorted and it is performed at a rated current. So, and also it is performed at very reduced voltage. So, if it is performed at a very reduced voltage, the core losses, as we see in the previous class, core loss is the hysteresis loss plus the eddy current loss, and this hysteresis core loss, or you can say it is iron loss, both are same. The hysteresis loss is depend upon is proportional to, you can say, is the frequency and the flux density, plus this eddy current loss is also depends upon the frequency square and the flux density square, and this flux density is proportional to your flux, because phi is equal to B A. Okay. Now, this flux is produced by the apply voltage, and in this case, and what is phi m? Phi m is V upon 4.44 f phi, sorry, Fn. So, this flux is proportional to the voltage, okay. And in this case the voltage is very reduced voltage, okay. So, and so this core loss is proportional to the approximately proportional to the V square, the core losses, because this term is also approximate proportional to the V square, and this is all obviously proportional to the V square, and the V is very less in the case of short circuit test, because you reach the rated, it is performed at a rated current. So, you reach the rated current by applying very small value of voltage. So, obviously the volt rating is very less in comparison to the rated voltage. So, this core loss is very less, okay, because this wattmeter power, because there is a no load, it is a short circuit, so all the power is consumed in this circuit, okay. So, that power must be the I square R losses and the core losses, but in this case you have seen the core losses are very less, because it perform at a rated voltage. So, this power is consumed by only gives you the copper loss, because copper loss is the I square R loss and I is the rated current. So, the copper loss has some meaningful value. So, this wattmeter gives you the copper loss, okay. And from that we will find that, or with this R you can use the short circuit or the ZHC, the short circuit impedance you will find with this, okay. So, ZC is equal to VR upon IR, that is VR is the ammeter reading and at short circuit, and the IR is the ammeter reading, or you can use this not R, you can use SC, it will be more convenient, that is a short circuit, okay. So, and so this power gives you the copper loss, because the wattmeter gives you the real power, this wattmeter gives you the real power, it does not give you the reactive power and all. So, this WSC you can write I square R short R, okay. So, this can be written as So, from here you can find RSC is equal to W upon ISC square, and ZHC you already got from this equation. So, XSC is equal to ZSC whole square minus RSC whole square. Sorry. Okay, and what about this RSC? RSC is the R1 plus R2, that is RSC, and XSC is X1 plus X2. So, we assume that the R1 is equal to R2. So, you will get this parameter of the and what are this R1 and R2? R1 and R2 are the, this R1 is the resistance, winding resistance in the stator, in the primary side, R2 is the winding resistance in the secondary side, and this X1 X2 is the, X1 is the resistance the leakage reactance in the primary side, and X2 is the leakage reactance in the secondary side. Okay. So, these all parameters you will find with the help of this short circuit test. Okay. So, if you conclude this first with this short circuit test, you will find R1, R2 and X1 and X2, R1, R2 and X1, X2. Okay. And second thing you will find the ohmic losses at rated current. Okay, because this is the variable losses, it will depend upon the load value, load current. So, it is performed at a rated current, so you will get the ohmic losses at a rated value of current. Okay. Now, you will see that this short circuit test is always performed at a high voltage side. Okay. So, these parameter you will get at a high voltage side. So, this parameter you will X1 X2 is always this at high voltage side. Okay. So, this R1 is okay, R1 is already a high voltage side, but if you find this R2, this is, if you this R2 is also the high voltage side. If you take at the low voltage side, you must be multiply with the turn ratio. So, that you will get the R2 is the in the low voltage side. So, these parameter are always get at a high voltage side, because it is performing at high voltage side. Okay. Now, so this is a short circuit test, and with this test you will get the R1, R2 and X1, X2 and the ohmic losses at a rated current. So, with this losses, because open circuit gives you the core losses and short circuit test will give you the ohmic losses, so that you will find the efficiency of the as well as the parameter concern. You will, by using these two tests, you will get the parameter of the circuit, and as well as the you will get the efficiency of the transformer also, because in open circuit test you will get the core loss, and in the short circuit test you will get the ohmic losses. So, the total losses also you will find with this two tests. So, it is also useful to find out the efficiency of the transformer. Okay. Now, we will see that in this content you will see one topic is choosing site to carry out open circuit test and short circuit test. So, why this open circuit test is performed always at a low voltage side. Now, see, just take one example. Suppose 1 kVA transformer is there, 200 volt by 100 volt, 50 hertz single phase transformer is there. Okay. So, this is 2 winding transformer and it is 1 kVA, 200 volt, 1 kVA. So, that this side of current is, suppose this I1 will be 1000 divided by 200. So, it is coming out to be 5 ampere. Okay. And what about this I2? It is 100 divided by 1000 divided by the 100. So, it is 10 ampere. Okay. So, it is 5 ampere and this is 10 ampere. Okay. So, if you perform the, suppose the no load test, the short circuit, open circuit test. Okay. So, in open circuit test is always performed at a rated voltage and at a no load current. Okay. So, here the rated voltage is 200. So, you just apply the, for this rating it does not matter, you apply here either in 200 voltage or in this is a high voltage side and suppose this is a low voltage side. We see we just discussed previously that the open circuit test is always performed at a low voltage side, because if you see this transformer, the current is 5 ampere, here the current is 10 ampere and here the voltage is 200 volt, here the voltage is 100 volt. Now, it is performed at a no load. So, the no load current is, suppose it is a 2% of the, or you can say 5% of I1. So, 5% of I1 is 5 into 0.05, that is 0.25, and in this case the no load current is 10 into, suppose the 5%. So, here it is 0.5. So, obviously, your 0.25, either it is 0.25 or 0.5, you can measure with the help of ammeter, because ammeters are available in the laboratory of a range of 0.25 or 0.5 or the voltage 200 and 100. So, in this particular rating, it does not matter the open circuit, either do you perform those open circuit test in the high voltage side or the low voltage side. Now, if you take the transformer of 1000 kVA and 1000 volt by 100 volt, 50 hertz single phase. Now, suppose this 2 winding, so the current is like sorry 100 kV. It is 100 kV. So 5% of 100 kVA, 5 ampere, and here 5% of 1000 is 50 ampere. Okay. So now if you perform the no load test at a high voltage side, suppose, so that means you apply the 1000 voltage, but 1000 voltage is not available in the laboratory. Okay, that is the one point, and second is the 1000 voltage is a very high voltage. Okay, so there must be many precautions you have to take place. Okay, so this is the reason why you use this. It is not a high voltage side. If the range is less, if the range is like 200 or 100 volt, doesn't matter. You open circuit perform either this side, high voltage side, or the low voltage side. But if the range is like this, so you must perform the voltage at this side, because 100 volt is already available. 1000 volt either it is not available, and you must have some another arrangement. Second thing is the precaution. It must be precaution, because 1000 volt is very high. So precautions has to be takes place. Okay, this is the reason. And with the help of, like, at no load, 5 ampere is either 5 ampere is flowing or the 50 ampere is flowing. So both currents range are available in the laboratory, and if you are using the wattmeter, so that the current coil is also carry this 5 ampere and 50 ampere, that wattmeter is also available in the laboratory. So this is the reason why we perform the open circuit test always at a low voltage side. Similarly, in short circuit test, it is performed at a test is always performed at a rated current. It is always performed at a high voltage side, because the rated current is, because it is performed at a rated current. So for high rated value of kVA, the rated current is very high. So that's why it is performed at a high voltage side, because in high voltage side the rated current is comparatively low in comparison to the secondary side. Okay. So this is the how we do the two experiments, the open circuit test and short circuit test, to find out the parameter of the equivalent circuit parameter of the transformer. So we have seen that in open circuit test we will get the no load parameter and the core loss. In short circuit test we will find the R1 X1, R2 X2, that the resistance, winding resistance, and the leakage impedance, leakage reactance. And second thing, from the short circuit test we will get the core loss, copper losses. And why this, next we will see that why this test will not perform at the open circuit test is always perform at, open circuit test is always perform at low voltage side. Okay, and the short circuit test is always performed at high voltage side. Okay, because it carry a rated current. Okay, so this is how this we will find the parameters and the losses. So thank you all, and if you have any query, you can contact me on KALRA SARIK Sarika @akgec.ac.in. Thank you.